Okay, we have liftoff, and welcome everybody, and thank you for joining us for our next presentation. My name is Matti Saarinen, and I'm the Sales and Marketing Manager here at Focus Solutions Finland, based here in Helsinki. Sunny or partly cloudy today. So our next presentation will be called Audio over IP and 5.1 Audio Monitoring for Broadcast Production, and it will be presented to us by Mr. Aki Mäkivirta. He's a R&D director at Genelec, which is a company based in Iisalmi, beautiful eastern Finland. And for sure, Genelec is the world leader and innovator when we talk about active monitoring speakers. And Aki has about 40 years of experience in digital signal processing and in high-end technology R&D. And again, a little bit of housekeeping. If you have questions, you can type them there on this side of the swap card platform. And if there are no questions, you're always welcome to connect us later. So please, let's switch over to Aki. The platform is yours.
Thank you, and let me share my slides with you. So I have two topics today, and hopefully you can see my slides. The first one is to talk about this big change in the broadcast industry, going to IP networking based communication and connectivity between devices. And then secondly, another change, adding more channels, so going from 2 channels to more than 2, and what this would mean for us. So let's start with talking about the IP networking and the challenges that this will pose on us. So basically, I think it's kind of safe to start with the broadcaster position. EBU has been working on this for maybe a decade by now, and they actually have very good papers on this. What I would ask you to do when you've finish this presentation, you could just pop down to EBU websites and check what kind of stuff they have available for you there. It's all free, and they have very good information about this change and this development. Basically, what broadcasters want to have is they want to apply standards, and the motivation for this is that they want to maximize interoperability between different devices. So they want devices to be able to connect together across ecosystems. What broadcasters are looking for, they describe at EBU as a pyramid that starts with the media transport. So this is the basic mechanism of moving video and audio over IP networks. And then, of course, you need synchronization between devices, a facility for that. Then you need the capability of automatically discovering and connecting devices across IP networks instead of having to do this manually for each device. And then you need a facility that automates configuration and monitoring of device status on the network. And finally, you need security. And you need security for eavesdropping so that unwanted parties cannot listen to your streams. And then you want protection against anybody interfering with your setup, interfering with your facility. So they want stable systems that they know are going to run. So these are the layers that broadcasters think they need in a well-working implementation of IP network systems. Historically, things haven't been working this way because we have a number of ecosystems in the audio industry that as long as you remain within the ecosystem, you're fine to connect devices. But if you want to connect devices across ecosystems, it hasn't been possible. With the introduction of a couple of standards, the AES67 standard and the SMPTE ST2110, we are now moving into a new era, so to say. We are moving into a situation where you can actually have interoperability across different manufacturers and different ecosystems. And this is one of the key things that broadcasters are looking for. So again, here, a lot of these documents are freely available to you. When you have the time, please take the time to just get familiar with this material. I think it's very important for you to understand this development, because this is going to be a big change in the industry in the future. So besides these two organizations, SMPTE and AES, working on the standards level, then we also need to ensure that things are actually working. And there's a testing organization set up for that. People are holding plug fests to see that things actually can plug together, can work together. So there's a lot of this kind of work going on in the industry. Also, there are industry associations or alliances working together to advance the capability of devices to work over IP networks. The chart here, this organization is AIMS. They are looking at the audio and video side of things. And you can notice here that regarding video, regarding audio, we are using AES67 as the core building block for things. So you can see how things are kind of connecting together here. Audio Engineering Society is working on the audio side. They create a standard, and it gets used in the system that also is supporting video. There are a lot of video companies in this media alliance, but you can also see some audio companies in this list of names. And this is not a complete list of names. You can see that this can be a significant development in the way we do things in the future. Now, Genelec is also supporting this change and this development, and we are getting ready to offer solutions for our customers for monitoring audio in the situation where everything is connected over IP networks. The first solution in this area is 8430. This is a loudspeaker that can directly connect to an IP network, can directly receive audio for IP streams, and also has the important facility for management and control and calibration on another network that enables you to align this monitoring loudspeaker acoustically in the space. And that's a very important thing and consideration for audio monitoring, and I'll talk about that next. But before I do, I'll just introduce you to another technology development that we are working on at the moment. And we have a couple of products already in the AV install industry where you can actually implement single cable connectivity, so that you just pull a single CAT cable, and that cable can deliver not only audio and management and monitoring and control, but also power into the loudspeaker. And this makes a lot of real life situations very easy, and this becomes a problem solver in many situations. And we look forward to implementing this kind of technology also in the broadcast industry for the broadcast monitoring applications. Okay, let's talk about the acoustical challenges that we have in real life situations. And Genelec is offering solutions that really we are not only delivering monitoring loudspeakers, but we are delivering system solutions that make the loudspeakers work perfectly in real life environments. After all, our main challenge is that for audio engineers, ears are their tools. They have to be able to hear accurate audio presentations in order to take the control actions they need in order to improve audio, in order to design audio presentations. Okay, let's run through some of the needs we have in this area. The first thing is that we need to establish proper geometry for the monitoring situation. We have this aim that we want to create this sound stage, these virtual sound images. This is the simplest case, couple of loudspeakers, a stereophonic system. And in order to do that, we have created and established an agreement. And this agreement places these two loudspeakers at certain direction relative to the listener. At equal distance, and this implies a couple of things. It implies, firstly, that the level from these two loudspeakers reaching the listener's ears is at the same level. And then secondly, this also implies that the time of flight it takes for audio to travel from the loudspeakers into the listener is the same for the two loudspeakers. Now, why this is important? Why is it important for us to fulfill this agreement in the studio for the audio engineer? One of the key reasons for this is that a lot of the work, a lot of the creativity that people are doing is actually using a level-based panning method. So basically you are placing your virtual sound image between the loudspeakers by using level panning. And of course for stereo, you know that in every mixing console has a number of these level panning controls readily available. If you have a more complex sound system, a surround system, maybe even an immersive sound system, you're still using the same principle, but your panning pot becomes a bit more complex. But the news here is that we are always using level panning as the main tool. So if we have a skewed monitoring loudspeaker system, for example, here, the distance from one loudspeaker to the listener is larger than from the other, then the timing will not be accurate. And when we now use level panning to create our audio presentation, then the presentation will not translate. When the customer is listening to our presentation, it is not what we intended. And in fact, it also turns out that you cannot compensate timing difference with adjusting the level, so that you cannot create this kind of compensation for problems in your loudspeaker alignment. It doesn't work in practice. But when we make things slightly more complex by adding more than two loudspeakers, we go into, say, 5.1 system, maybe even an immersive layout. Essentially, we have to build on the same principles. So we have to be able to align our loudspeaker system for levels and times of flight for audio in order to deliver accurate monitoring experience. Now, Genelec is supporting that with this automatic calibration tool that basically is connecting to all the loudspeakers, subwoofers in your monitoring space. And we actually listen to the space. We build this measurement microphone in eSalmi that you can place at the listening location, and you can actually find out what is happening regarding levels and timings. And this kind of system can compensate any size of monitoring system. It could be 1 or 2 channels, it could be 5.1, or it could be immersive. We support all of those. So regarding timing and levels, we can find out exactly how things are working, and we can introduce compensations and settings in all of these smart active monitoring loudspeakers that take care of this problem for us. But there are also other influences regarding acoustics when you start placing monitoring loudspeakers in monitoring rooms. So this is a pretty nice monitoring room, but you can immediately see that we can potentially have some acoustic challenges here. Consider, for example, the large desktop here that can reflect audio. But things can be even more mundane, like here we have just put monitoring loudspeakers next to the displays. That's the place we have available for them. So they will experience the environment. The audio will be modified because we just stick the monitoring loudspeakers where they can go. So as long as we can have the correct directions for the loudspeakers, we might get a lot of influence by the room to the quality of sound. Let me quickly run you through a couple of these influences, because after all, what you hear is the combination of the room influence and the monitor loudspeaker sound quality. Reflections are a significant factor because they can color audio in the mid-range. Then low frequencies are boosted when you place your monitoring loudspeaker next to an acoustically hard surface or close to a corner. Then many rooms resonate, so you can have a big influence of your seating position unless you compensate for this kind of effect. And then resonating rooms can actually not only color audio, but they can also hide some details at other frequencies because of this coloration problem. Now, for all of these things, we can actually listen to the room. We do this in Genelec by building in a measurement signal into the monitoring loudspeaker and subwoofer. Then the Genelec measurement microphone hears how the room sounds. And we take this to the Genelec cloud, and we can calculate the time domain impulse response of the room. We can calculate the frequency response. So we now understand completely how each and every monitoring loudspeaker is behaving. And then we can go away and we can calculate compensations for each individually on each monitor, each subwoofer. And we can have a well-aligned monitoring loudspeaker system. We can compensate for the room effects. We can align subwoofers with the main monitoring system. And this just makes monitoring so much more precise and enables you to just take your monitors, place them anywhere, and get up and running in a couple of minutes by using this approach. There are no hard limits to the channel count. We support more than 80 channels of monitoring loudspeakers in one room. And at the moment in our product selection, we have 26 different monitoring loudspeakers and subwoofers that enable you to build any size of monitoring in the broadcast industry for any channel count. And with GLM software, all of these can quickly be integrated into a system. So that was a quick introduction that we talked a little bit about the IP, then a few words about the practical challenges, particularly with multi-channel monitoring situations such as 5.1, where you are making things slightly more complicated because you are adding more than 2 channels into the room. So you need a more careful alignment in order to deliver the sound images and the sound stage accurately, despite the room, despite some errors in the distances of the loudspeakers. So do we have any questions at this time?
I was monitoring the swap card panel, and there are no questions. So, but for the audience, please do not hesitate to send us the questions afterwards, either for us here at Broadcast Solutions or to Genelec. If it's a difficult question, better send to Lucky.
Of course, Matti, I could interview you. So, did any questions pop in your mind about these topics?
Not that I know.
How do you find this change to the IP technology?
Well, really interesting, and thank you very much, Aki, for your presentation. So, and we wish everybody a good day, and cheers from here.
Okay, thanks very much, and have a good day.